Great to be here. I heard a rumor that Atlassian don't really get to interact with many Australians on a day-to-day basis, so I thought I'd come and try and help out with that. So I'm at Square at the moment, and what I wanted to talk about tonight is some work that myself, and a couple of other people at Square worked on during our last Hack Week and have been chipping away at since. It's a project about Rubygems and security, but it's not necessarily specific to Ruby. So who here uses Ruby the day-to-day? They know how it works, like Python, Java, other stuff. Yeah, doesn't really matter. What I'm talking about today really applies to packaging systems and securing packaging systems. I'm going to talk about Rubygems because that's what I'm most interested in. But yeah, hopefully you'll get something out of this even if you don't even know what Ruby is. So first of all, I'm up here today talking about this, but it's not a thing that I did by myself. So this is a point where I would normally point out people who helped me out, but none of them are here tonight. So thanks, guys. But no, these guys really put a lot of work into this. I'm sort of just talking about it. So this is something that we did at Hack Week. So this is something we do at Square 4 times a year. We just take a whole week as a company, and the whole company just works on stuff that is useful for us, or we think it'll be a cool product, whatever. And this is the outcome of that. So let's start with, how do we attack Rubygems? How do you attack a packaging system? Because what we're trying to do here is, there are problems with a packaging system, and if you need to trust certain things, you don't want to be running arbitrary code. If you think, oh, I'm a malicious attacker, it's actually a pretty good vector to try and attack a company, right? Is via a packaging system. So okay, how do you attack a packaging system? Also, arbitrary software installation, that's the easy one. You present up a bogus package somehow, you man in the middle of them, you compromise their server, whatever, you run arbitrary code. Rollback, so you can force somebody to install a version that's older than the one that they have, so an older version with a known security vulnerability. You can indefinite freeze, so you can prevent people from getting new updates. You can do an endless data attack where they just keep downloading data and it's like a denial of service. You slow retrieval. Like, this list just keeps on going. And this is something that I didn't even really know about, right? I sort of just considered the top one and thought, yeah, that's a problem. And then started thinking about it, started reading about it. A lot of people have done a lot more research into this than I have. And mix and match, getting different versions of software, wrong software, malicious mirrors. It's endless, right? There's all these problems. And okay, so these are the theoretical ways you could attack a packaging system. Which of these is Rubygems vulnerable to? Anybody know? All of them, correct. That's pretty scary, isn't it? And this is primarily why we started working on this problem, because we find that quite scary. And it's actually not just Rubygems, most packaging systems are vulnerable to at least some of these, probably most of these. Oh, I forgot one, keeper compromise. All right, so what are we talking about this talk? Where are we today? What is the current state of Rubygems? Where are things at? What do we need going forward? An introduction to the update framework, which is the system we have applied to try and secure Rubygems, and the current status of the work that we've done. That's the roadmap. That's what we're going to talk about. So today, Rubygems actually has some security features. You can sign your gems with your private key and then publish your public key, and people can verify that that gem was published by you. So this is a thing that you could do. This has been in Rubygems for 8 years or something like that. It's a little bit of a problem because you have this key distribution problem, right? Where let's say you sign it with your private key, then if I'm a developer, how do I find your public key? You have to publish it somewhere. I have to go to the effort of finding it. It's kind of just a bit of a pain, right? There are some other problems with it as well. If you have a project where you have 11 people on the team who can all release the software, how do you do the signing? Do you have a shared key between everybody? Then what happens when somebody leaves the team or goes rogue? You sort of have to revoke everything. And there's some practical problems like that. And the result of this is pretty much that this feature is really just not used. I don't know anybody in production anywhere who uses this system to verify their gems. So as far as I'm concerned, it's not a security feature because it's never used, right? So yeah, most gems aren't even signed. The ones that are, there's not very many of them, and yeah, mostly unused. The other big problem here is that this isn't a theoretical problem. So early last year, I think it was about April, Rubygems.org, so the main server that hosts all of the Rubygems, got hacked. Somebody got root on this box. And that was a big problem. I don't know if anybody here remembers this, but Heroku had to shut down deploys for 3 days. There was really no way of recovering from that. They sort of had to pull a backup. There was still a lot of like, oh, we think it's fine. They found a couple of gems that had been modified. Like, this was really bad. And so this isn't a theoretical like, oh, we need to secure things because maybe it'll get hacked one day. This has already happened, and it was a total mess. So I think this is a really important problem that needs solving. The requirements. So this is, what do we need from a system in order for it to be useful as a solution to this problem? First one is it has to be on by default. Right? We saw this problem with the existing signing solution that's already present, in that it's not on by default, people don't use it. Right? If you have a security solution that 10% of people use, it's not good enough. You need 99% of people to be using this. It has to be opt-out rather than opt-in. No external dependencies. This is actually a little bit of a tricky one, because there are a few things, for instance, like PGP, right, which is an existing solution. Some people have proposed this as a solution. You could do like a web of trust type thing. The thing is, once you put an external dependency in there, like on an external security library, then you need to, well, okay, does it work on Windows? Does it work on all these other systems that Ruby supports? It becomes a real deployment nightmare. And it's pretty much a non-starter, and the core Ruby guys, the core Rubygems have publicly said, they're just like, we can't do that. Like, it's not a thing that we can ship, not a thing we can support. So it has to be based on the existing stuff that we ship with Ruby core today, which is, there is some, pretty much just OpenSSL support is really what you get. And the other thing I really want is I want it to be standard. Like, I don't want to have to invent this. I don't want to have to write security code, because the first rule about security code is don't write security code. You will get it wrong. And if you have to write security code, don't invent security algorithms. So I really want to, where possible, reuse existing work. Now, we are going to have to write some stuff, right? We don't want external dependencies. So kind of the implication of that is, well, we're going to have to write some code. But where possible, I want to be implementing algorithms that other people have come up with. So those are my criteria, and that's how we've evaluated different approaches to solving this problem. Enter the update framework. So the update framework is a project. It came out of Tor. If you're familiar with that project, it's an anonymous proxy thing. They were trying to figure out, how do we securely distribute this piece of software? So it's a package management, package distribution problem. And so they did a lot of work. They had a system. I forget the name of the original. The update framework sort of came out of that. There's a couple of professional security researchers over at New York Poly who have been working on extracting that out and making that a thing. They've got a lot of students working on this as well. And so it's sort of this standard framework that defines all of the attacks that I listed right at the start of the talk. And then they've defined a framework to prevent or mitigate those attacks. So this is really cool. They've already got a proof of concept for securing the Python package management system, which they're trying to roll out at the moment. So it's and also they've got that experience with Tor as well. So it's a thing that's been deployed at least once. They're in the process of deploying it to other things, and they just have a whole heap of stuff that we can sort of lift up and dump on top of Rubygems. So that's pretty cool. What I'm going to do for the next section here is explain what the update framework is, how it applies, and pretty much how it works. This process, once again, I'm going to use Rubygems, but this will apply to any distribution system you have. So I'm going to build this up. I'm going to start with a system that doesn't work, move to a system that works better but still doesn't work, and eventually, at the end, we'll have a system that works pretty well. So if you think about, is everybody pretty much familiar with like public-private key signing stuff? Right? So if I have a private key, I can sign it, somebody can validate it with my public key. Right? That's how we do this. This is all based upon that. So I assume you know what that is. So you imagine the simplest possible scenario. Imagine we have a file server, right? Like, I have a gem that I want you to get. I'm going to put it on the file server. Then you need to download it off the file server, right? So I push up my gem. And then it needs to be signed somehow. right? So for now, we'll just say, okay, there's a Rubygems maintainer who signs this gem, right? And they use an offline key. So what I mean by an offline key is this key isn't on the internet. It's kept in a safe somewhere, and there's a new gem, and they open the safe, they take the key out on a laptop, it's air-gapped, right? They sign it, they put it back in the safe. So if rubygems.org gets compromised, you can't access this private key. That's the whole point of this. This is why it's an offline key, right? And then you can gem install, and you can get this key, and then you can, if we're distributing the public side of this private key with Rubygems, you can then validate that, yep, Rubygems signed this and thought it was great. So this is pretty freaking secure, right? Because you can't get the offline key unless you actually compromise the safe. And you can even do it where you have 3 safes owned by 3 different people and you need to have a threshold amount sign them or whatever. But this is about as secure as you can get, right? It's really hard to compromise this. You hack rubygems.org, you don't get anything. You can denial of service, obviously, but you can't serve up malicious software. Thing is, it sucks. Because every single change that comes up, you need somebody to actually open up the safe, pull out the key, sign the gem, right? So that's just a non-starter. That's not going to work. But this is really secure, right? All right, so let's try and fix that safe problem. So we'll try a different way. We'll do online signing. So what this means, same thing, gem push, except rather than a person pulling a key out of a safe, we have a robot, and the robot signs the gem for us. Then we download the gem and we can verify it, and we'll be pretty happy about that. So this gets the person, the Rubygems maintainer, out of the loop. So that's pretty good. So this is much more usable. Downside is that now if you hack rubygems.org, you have the robot. So you can just robo-sign whatever arbitrary stuff you want. So it's not as secure. People with me so far? Make sense? Good, see a lot of nodding. But, so, it's not good enough, right? Because it's a little secure, but it's really just not that secure, right? All right, but here's what we do. We can combine the two. So hybrid signing, how this works. Gem push, robot signs it, somebody installs it, and then once a month, Rubygems maintainer comes along, re-signs the gem with the private key, and then next time when it gets installed, you can verify it against the offline key rather than the online key. Yeah, so a little bit trickier. What this does is now, so when you push up a new gem, we're robo-signing it. So you're not protected from a Rubygems compromise, but you are protected from certain attacks like man in the middle, like a malicious mirror, even just file corruption, right? So there's still some protection there. It's still kind of useful. For old gems, so gems that have been there longer than a month, as long as you can relatively assume that you haven't been hacked in that month, you can actually get that offline guarantee, right? So this is starting to feel better, right? One of the really good things about the system as well is it's on by default. So if you notice the user interaction here, the gem push, gem install, nothing changed. We could do this today without users having to change their behavior at all. So I think that's really cool. So this is starting to look really promising, right? Still not great though. You've still got this window where wherever you push a new gem for up to a month, it's vulnerable. Yeah, because everything before it gets signed by the offline key, you can just get the robo key, you can hack Rubygems, and you can serve up invalid things. So what this means in practice is that every time you push a new version of Rails, right, one of the most popular gems, it's vulnerable for up to a month. So that's pretty unacceptable. So hybrid signing, that also gets rejected. But we're getting closer. So let's try this one more time with a thing called developer signing. Now here's how this works. It's a little bit more complicated. So I'm a developer, I have my own gem, I have my own private key. And so I sign my gem before I push it up, and then I push up both the gem and my public signature of that gem. Now what happens is the robot doesn't sign the gem itself, because I've already signed that. It signs the metadata that I pushed up. So the robot is signing the thing that I gave it that says this is legit. Once a month, the Ruby maintainers come along with their offline keys and they can promote that to the offline key. Then now what we're doing is we're distributing my public key via this robo-signing / offline signing process. But when they do a gem install, they're actually validating with my public key against that private key. That was a lot of words, but the effect of this is now when I need to push an update to the gem, you can see here that my public key doesn't have to change. Right? So for the first month where I've pushed my very new gem and they don't know who I am, everything is vulnerable to Rubygems.org getting hacked. After that first month, I can push updates without having to go back through that quarantine period again. So that's a little bit complicated. Does that kind of make sense? So this is what we want. This is really good. So the summary of that is rather than having Robo signing the gem content itself, you sign the metadata about the gems. That's really the key point here. And this is the win we get out of it, and this is what makes this better than the solution we had before. Once you get your gems promoted into old space, they're pretty secure. So that's a basic introduction to TUF. That's the general outline, general framework. I can't go into all the details here. What I've hoped to do there is give you enough of a concept of how it works that if you want to go and read the spec or read through some of the documentation, you'll have a mental model of how it works. Right? So I'll give you some links at the end here if you want to read further about this. There's a lot more stuff in here that it can do. Threshold signing, so that addresses the problem I said earlier where if you have 11 maintainers, you can say, okay, well, 3 of them have to sign for this release, and it's pretty easy to revoke individual developers. Freshness guarantees, so there was a problem I mentioned at the start where you can effectively block updates by you keep serving up old metadata to clients if you're malicious, and then they never get new updates of gems. There's some stuff built into this where it does some timestamping to make sure that you know that you are getting an old metadata file and you can deal with that. And then consistent snapshots, which is kind of a nerdy thing, which means that you can't mix and match different gems and makes it all work across CDNs. So it's kind of interesting, but not really relevant. And there's a few other things as well. Pretty much, you read the spec and you're like, wow, you have thought about this a lot. And I really appreciate that. All right, so current status of this. You can use gem install to install a gem, and it will use TUF. This is pretty cool. You have to opt in, and sorry, this isn't a thing that's been released. You have to use like the custom branches and stuff, but this is where we're at as far as development. So you can gem install, tell it to use TUF, and it will. If everything goes fine, you won't even know about it. If something malicious is going on, it'll raise an error and be like, nope. It's a terrible error at the moment. It'll just be some random exception, but we'll fix that. There's this script here that I provided, because if you use gem install, you're like, well, I don't really know if it worked. So I created another script which actually shows you everything that it's doing. And you can see here that it's actually going through and fetching like a timestamp file that does the freshness stuff, the release that does the consistent snapshot stuff. You can see there's some shars in the file names here. Et cetera, goes through the targets, and then eventually fetches the files based on the stuff that it got out of the metadata. A lot of this stuff, it looks like, wow, that's a lot of round trips, but you can actually cache a lot of that and fetch them all in parallel, and it all works out pretty nice. So, and this is all CDN-able, so we can distribute it all out so it's really fast. So that's pretty cool. You have to jump on, there's a branch for rubygems.org, which is the server component, and there's a branch for Rubygems, which is the client. And they both have the same branch name, currently TUF Xavier. It changes whenever I do new work, but that's the current one. And so if you want to go and look at that, you can go and play around with it. Future work. So where are we today? Where do we need to go? So that's where we are. We have a very basic proof of concept that's like, yeah, this is going to work. I am quite confident that this is a good solution that works, that we should use. I think it addresses all of the problems that we have and doesn't have any significant downsides. So I'm all for it. Future work. Somebody actually, I think, started working on this, but actually this is a non-related problem, that the current server component doesn't work with the most recent client, which actually makes it very difficult to develop. So this is actually unrelated to TUF, but it has to happen at some point. We need to support bundler. In theory, it all works. We just haven't done it at all. So this is both supporting, there's a couple of endpoints that bundler talks to that need to be secured in this way, like that Rubygems itself doesn't use. There are also, like the bundler fetching has to be using TUF as well. The bundler fetching is pretty much the same as the gem fetching, so it all just should drop in pretty easily, but just hasn't been done yet. Handling developer keys. So currently the system that I have, you can do the robo signing bit and you can do the Ruby maintainer offline signing bit, but you can't do the bit where a developer signs a gem and uploads it with the manifest. Because that'll actually require a new API endpoint on the server, because now you're not just pushing a gem, you're pushing a gem plus manifest. So that bit hasn't been done yet. Some sort of security audit from people who know what they're doing. The New York Poly guys are on board. They've already been giving us code reviews, which have been really good. Like, you can't do that, it's insecure. You can't do that, that's also insecure. Why did you even write that code? So that's been really good. And I'm like, it was just a prototype, please. So I'm pretty comfortable that will happen. But more eyes is always better, especially for security-related stuff. So if you've got sort of an inkling to even just read the code, that's actually really useful, particularly for this. And then there's just a heap of to-dos. The current version is very much a happy path type thing. So particularly, like, if it breaks, you just get a random exception. And there's like a whole heap of to-dos about, well, I won't even try and explain them all, but if you're just looking for like a quick thing to do, you just grep for to-do out of all the TUF code. There's a heap of stuff there. So that's the future work. More reading, just put some links up here. We can probably share this deck somehow afterwards. The update framework, updateframework.com, that's where you would go to read the spec and everything about the update framework. There's a pull request there. That's actually old. I should get rid of that. You should use the link in the previous slide about where all the latest code is. There's a Gems on TUF implementation. So this is actually from the students over in New York. So there's sort of like a reference TUF implementation, and they've done a Rubygems server using the Python reference implementation with TUF, kind of. The most useful thing about it is it actually provides you like reference copies of all the metadata that you can be like, am I generating this metadata correctly? Yes, because I can compare it. So that's pretty cool. And then the next link is where all that metadata is. One link I forgot to put in here because I published it after I made the slides. I did a blog post, a series of 3 blog posts on corner.squareup.com that sort of goes through this in a little bit more detail. So that might also be worth a read as well. If you're like, I sort of got it, but didn't quite follow everything, the blog posts are sort of a little more detailed version of this talk. So corner.squareup.com is where that is. And that's pretty much everything I have to say about the topic. I guess I have a heap of time for questions based on the schedule. I'd be surprised if that was interesting enough for half an hour's worth of questions. But oh, I didn't update my slides for the thing. Oh, well, just ignore that. That's not where we are. I'm sorry, that's really embarrassing. So yeah, does that make sense to people?
It's so small, I don't think anyone noticed.
Yeah, I shouldn't have called it out. Yeah, so is that, oh, thank you.
Huge thank you.
Yeah.
Awesome. Yeah, okay, so I guess we'll start with questions. If you have a question, raise your hand. I'll come by with the mic and.
Yeah.
Hey Xavier, nice to meet you, man. Can you quickly describe the offline signing process?
Yes.
I'm really intrigued. Is it someone with a USB key runs up to a server and plugs it in and types a command, or is it more? Pretty
much, yeah. Okay. I mean, you don't necessarily have to go to the server. It's so you can imagine. So in the ideal world, what you would do, and depending on how paranoid you are, you can. Somebody will probably be like skewer me for this and say that's not secure enough. But you pretty much download the file you need to sign, unplug your internet, plug your USB key in. USB key's got your private key on it, or like floppy disk or some removable media, You run a script that signs the thing you're trying to sign and generates a signature. Then you unplug your USB key, plug your internet back in, upload both into the server. That's basically it. So it's kind of onerous, which is why you only want to do it once a month or whatever. Yeah.
Not sure I expected to hear floppy disk tonight, so
Yeah.
it's a win.
I put that in like the instructions for a thing, like for another thing where generating offline keys, and somebody's like, do I really have to use a floppy disk? I'm like, well, if you want to be secure.
Do you guys have any other questions? Yep.
So this might just get too technical, but like you sign the manifest, but you don't sign the actual updated source. How can signing the manifest make sure that even as the source changes that it's protected?
Good question. So you sign the manifest at the Rubygems server level, but the actual source is signed by the developer. So it's still signed, but it's not signed by the Rubygems infrastructure. So what that means is if you're a developer, you need to know the Rubygems public keys, and you need to know the developer public keys, right, in order to verify everything. Now, the traditional problem has been, well, how do you get the developer keys? Right, that's the tricky bit. So what TUF does is it provides a distribution mechanism for the developer keys. And so through this TUF mechanism from the Rubygems server, you can securely and trustworthily, it's not a word, you can securely get the developer public keys to allow you to verify them on your end. So
The manifest basically links you up with the developer.
correct, yeah. And so it's a little bit weird. You still need to, like, I haven't talked about how do you, as the Rubygems server, make sure that you're actually talking to the developer. That's not really part of TUF because that's sort of like a different solved problem, right? It's like, how do you do authentication on the internet? It's like, passwords and two-factor and that sort of stuff. So that's still a part of this. And actually, I should have mentioned that in future work, but I didn't because it's not directly related to TUF. But there's actually some stuff that has to go on with the Rubygems, like authentication stuff, that just needs a little bit more work. Like I'd like to be able to two-factor my gems if I could. So.
Any other questions? Okay, well then, if nobody else has any questions, we really appreciate you coming out here, helping us meet our Australian quota at the office today.
Good, excellent.
Huge round of applause. Thank you so much.
Thanks, everyone.
So you guys, thank you so much for coming. We do these, every once in a while, and we have Yehuda Katz coming to our next one. So stay tuned, pay attention to stay tuned, pay attention to our website for the date on that. We're really excited to have him here. It'll be awesome. He's almost as famous, not quite, and he's not Australian, so, Thanks again for coming. We have tons of food, so please help yourselves. If you have any questions, a lot of Atlassians are running around wearing these lovely DevDen shirts, unless you already put yours on from when you got them at check-in, which would also be awesome. But come find us, come say hi, and thanks for coming.